In this video, we're going to look at evaluating functions at given values. Our function for this video is g of x is equal to the square root of x minus 1 plus 6. Notice that plus 6 is on the outside of that square root. And we want to evaluate it at x equals 4 and at x equals 10. Now, this is something I haven't talked about very much in the last videos, but it's something I wanted to mention eventually as we're evaluating functions at given values. Whenever you plug an x value, say x equals 4, into the function, whatever you get as your output is going to be a y value. So if you ever had to graph something, like if we wanted to graph the square root of x minus 1 plus 6, what you could do is you could always choose x values and plug them in, and whatever you get out of that would give you y values, which you could then match up with ordered pairs, plot the points, and connect the dots, giving you the graph. In general, anytime you're evaluating a function, though, you can just kind of understand that what you get as your answer is going to be a y value associated with that x value. So if a question is worded, find the y value associated with an x value of whatever, then all you have to do is plug whatever that is into the function, and your answer will be that y value. So really it's the same type of problem. So I just wanted to mention that before we jumped into this working out g of x at 4 and 10. So let's go ahead and evaluate this function at 4 first of all. So again, what that boils down to, if we're looking for the g function evaluated at 4, that just is saying we're looking for the g of 4. So we're putting 4 into the place of x. So everywhere we have an x, we're going to put a 4. So x minus 1 is going to become 4 minus 1 under the radical. And then the plus 6 comes down. So now 4 minus 1 is going to give us 3. And so what we end up with is the square root of 3 plus 6. And that's actually going to be our answer in this case, which is kind of surprising. You would expect to have to do more work. But 6 and the square root of 3 are not like terms, so there's no way we can combine them. So we're done. So now let's look at the second one. We want to evaluate the g of x at x equals 10. So again, what we're looking for is the g of 10. We just want to put 10 into the place of x and get our y value. So instead of the square root of x minus 1, again, we're going to have the square root of, in this case, 10 minus 1, and then the plus 6 on the outside. So of course 10 minus 1 is going to give us 9, so we'll have the square root of 9 plus 6, don't forget to bring that down, and the square root of 9 is going to be 3, plus 6 is going to give us 9. So the g of 10 is equal to 9. Now there's something I wanted to mention right here, because we've talked before about the principal square root, and this is a really good prime example as to why we have to have that. Remember, the principal square root is just the positive version of the square root. Because technically, if you've taken the square root of 9, you could have two different solutions. You could have negative 3 and positive 3, because if you squared each of those, it would give you 9. But the reason we have this thing called the principal square root, which is where you just take the positive version, is because, in this case, g of x is a function. We want to treat it like a function. So whenever you get your answer from taking the square root, we only want to take one of those values. Because if we took two values, it would not pass the vertical line test, and therefore it would not technically be defined as a function. So this is a good case to kind of look at. And whenever we have to apply that principal square root, this is why, because we want g to be a function. So I hope this video was helpful. Thank you for watching.